Hello and welcome back to our series going through the Physics GCSE spec. Today we're going to be looking at velocity time graphs. Now this is very similar to when we went through distance time graphs in a previous video. Make sure you check that one out if you haven't already. In this one we're just going to simply look at labeling the graph. It's very similar to what we did last time, but this time using the specific words that we need for velocity time graphs. So let's go straight in with our labels. So first of all, we've got this V here, which, as you can probably already guess, stands for velocity. Now, the standard unit we would normally have here is meters per second. You can have some other units, so make sure you double check that. Really common that I've seen is they might put this into kilometers per hour and have the time in minutes, because that's normally kind of how you might talk about a car journey. So just double check that when you get a question. The other label is down at the bottom here, and this is time. Okay, normally in seconds, however, like we just said, this can be in minutes, this can be in hours, days, weeks, whatever. Okay, so just double check that as you go through. Now, before we get into the main kind of lines that we can see here on our graph, we need to talk about the gradient. What does the gradient represent on our graph? Very similar to what we did when we looked at distance time graphs. So once again, go check that out if you haven't already. When we talk about a straight line on a graph, we think about y equals mx plus c. Now, like our distance time graph, this c kind of gets cancelled out because the c equals 0. Okay, we go through this origin point here. Okay, so c is always equal to 0, so it kind of gets cancelled out in the end. So we're going to end up with, we want to find this m, this gradient. So we end up with m equals y divided by x. And if we put our specific words in here on our velocity time graph, y is a change in velocity and x is a change in time. Now, the way we can write this, gradient equals delta v. Comment down below what delta symbol means over delta t. House points in that if you can get that one right. That was in a previous video, so go check it out if you're not quite sure. So we basically end up with this, and we know from the last video that we did that this is equal to a, or acceleration. So on a velocity time graph, gradient is equal to acceleration. Perfect. So now whenever we talk about these lines, we can talk about the acceleration of whatever object we have. Okay, so let's talk about this first line, this one right here. Just make it a little bit easier. Let's color it. Let's go with red, this first one. Can't remember what color we did for the distance line graph one, but this is red line here. Now, how can we describe this red line? Well, we could talk about the gradient. The gradient is quite high, so it has a high gradient. We could say that as a high acceleration. Is a straight line, which means that acceleration is constant. Okay, so we can say a high constant acceleration, and it's traveling positively, it's going up. Now this only shows positive, this graph, but we can assume this is positive, so it's away from origin. Which means overall this is a high constant acceleration away from our start point, okay, which is that 0 down at the bottom. Okay, now if we just go to this line here, which we're going to put in blue, here we can see an example of a lower constant acceleration. Now, remember this is all comparative. Okay, I'm calling this one high because it's the highest acceleration. Compared to a jet engine, it might be very low, but we don't have any numbers, we don't have anything else to go off, so we're comparing the lines to each other. So this is a lower, once again, straight line. It's constant acceleration and also away from origin. Perfect. Now we've got this kind of story going on in the middle here. Let's leave in green. So we've got this straight up part here, which we've kind of already described. We could describe that as a medium, constant acceleration away from the origin. Then we've got this flat part here. We've got this part that then goes back down. Now let's talk about this flat part. This is probably one of the most common misconceptions. So many people, so many students confuse these with a distance time graph. On a distance time graph, the gradient is representing speed, which means a flat gradient, zero gradient, means that the object is stationary or at rest, it's not moving. This is a velocity time graph. As long as that line is above this zero, it is moving. Okay, at this point, we would just say it has constant velocity. Okay, and in this case, we can assume that these are positive numbers, so we could say away from origin if we wanted to. Let's put that in, away from origin. Okay, but that is constant velocity. If we put an arbitrary number on here, if we just say that is 10 meters per second, let's say here is 5 seconds, here is, that's 1, 2, 3, 4, 5, 6, oh, that would actually be 6 seconds, go off in ones, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, just put some random numbers on here. So we would say this is a constant velocity of 10 meters per second away from the origin. Now when we come to this, the last part of this journey, in this part, we would say that this is a constant, it's fairly medium if we compared it to the kind of other lines that we've got on this graph. You could say it's medium, but I'm not going to put high or low on this. You can if you want to. It's a constant deceleration towards the origin. Okay. Now the reason I put deceleration is we're slowing down, and that's our special word for when we're slowing down. We say something is decelerating. Okay. Okay. They're all our labels. Now the last thing is probably one of the most important things, and one of the things that the most marks always thrown away, and that is talk about total distance on a velocity time graph. Okay. Now total distance is equal to the area under the line. And what I mean by that is, let's just look at this section here. Okay, actually, let's do it in a different color, just so we don't get it confused. Let's go with an orange. So we're going to talk about this section here. We want to know how far the distance traveled between 0 and 6 seconds. So we need to find this area. Okay, now really simple, back to kind of maths basics, finding the area of a triangle. We're going to do base times height divided by 2. So base 0 to 6 is 6 times height, we said was 10, divide that by 2. So here, the distance of 30 meters. Okay, and that works because, and I'll just put this in this total distance here, we know our equation is v equals s over t. So speed equals distance divided by time. I'm using these symbols because I follow the Pearson GCSE. If you follow a different exam board, you might know this as v equals d over t, or maybe even s equals d over t. Okay, but I follow Pearson, so these are the symbols that Pearson want us to use. Now, if we want to find distance, that is s equals v times t. So distance equals velocity times time. Now, when we go back to this area here, now I've just got it the wrong way around, but this is t, this 6, and this 10 is our v. Okay, so we are doing speed times time. The divide by 2 is just because it's a triangle. Okay, you could do the same thing. Let's use a different color. So for like it's what, purpley pink. Okay, if we wanted to choose this section here, we wouldn't need that divide by 2, and we would just look at what's the distance between the 6 and the 15. So that is 9. Okay, and that is, remember, 9 seconds. And the height, well, we already know the height is 10 meters per second. So this area is, doesn't matter which way around you do this, 10 meters per second times 9 seconds equals 90 meters. So this shape, this rectangle represents, nearly a square rectangle, represents 90 meters. Okay, and then we can find that final bit, add them all up, and that would be the total distance for this journey. Most exam questions will say what is the total distance travelled between time A and time B. So you only have to really do a portion of it, but if you needed to, you could do that whole journey right there. And that is the basics of velocity time graphs. In the next video, what we're going to do is we're going to take an exam question, or maybe a couple of exam questions, and work our way through looking at speed equation, distance time graphs, acceleration equation, and velocity time graphs. Okay, we might also throw in a small bit on one of the other acceleration equations, but we might also do that in a separate video.